We will now discuss an important DNS attack named DNS spoofing / cache poisoning. You can use these words interchangeably. DNS, or domain name server, is a piece of software that translates human readable domain names such as google.com, facebook.com to IP addresses that are used to route communication over the internet. Normally, if the server doesn't know a requested translation, it will ask the next DNS server to do this translation for it, and so on and so forth. This is called recursiveness. To increase the performance, DNS servers usually cache these translations locally for a certain period of time before it expires. And this means the DNS server that caches these requests receive a similar request from a client. Next time, it will not go into the recursiveness or will not forward the request to the next DNS server, but will reply directly from the cache. So here is the vulnerability. When a DNS server receives a false translation of a domain name to IP, it will cache this false translation for optimization purposes, of course. And now we consider the DNS server as being poisoned. So it will supply the client with the wrong IP address, which is usually an attacker's IP address, and a different type of attack there will start. So let's go directly to our Kali machine here and do some examples. For this purpose, I have created a fake page on my local machine in which I will redirect the users to. It's under var www html, and if you list here, you will see the index. We'll open the index.html file, and you will see that I've created a very simple HTML page just with this sentence here: you have been hacked. So now whenever the user, our target client, will type on his browser, we will redirect him to this page. We will use the ethercap application again, but before going that, let's do a couple of things. We have to do some configuration here. Kate ether.conf. That's the ether.conf here. So I will copy it and we'll open it here. So before you start with this attack, make sure to change the UID and GID to 0. Default configuration starts with 65. So whatever number is here, just make sure that it is 0 so you can use this file. Next thing, we will as well locate the ether.dns file. Copy again this file. Open it. Actually, this is the file that will have the fake DNS entry. So these are all commented entries. You can see this file, it has lots of translations. We're interested in these translations, so make sure to comment microsoft.com entries for the host name. Just make the pointer there without comment and add this here. So add a star, so any request that comes here, I'm creating a host entry and we redirect them to this IP, which is the local IP. And make sure to save the file and then close the file. Now open the ethercap application and then do sniffing on the interface, then go and scan for the hosts. Now we discovered these hosts and here you go. These are the hosts available on the network. We are targeting this machine, which is the Windows 10 machine. So add it to the target and then go to the MITM and press on the R poisoning, sniff remote connections and start. Next, we'll have to load the DNS spoofing plugin. And here you go. Everything now is up and running. If you go to the machine, Windows machine, and try to open the browser, just type here www.google.com. And here you go. The DNS has been spoofed and you have been redirected to my own page. Here another type of attack might kick in, like we will see these attacks in the web application section. You can create fake pages that similarly look like other famous pages, etc. So actually this kind of attack can be mitigated at the transport layer or application layer by performing end-to-end validation. A common example is to use TLS and digital signatures. For example, here, if you open a page that have HTTPS, you will not be able to perform this kind of attack, like Facebook. So this attack failed now because the user or the browser is checking whether the server's digital certificate is valid before establishing the connection. So this will not work. This will only work on websites that do not use encryption.